It is my pleasure to present Aapo Hyvärinen. That's my best attempt at the name. We're delighted to have him. Aapo is a professor at the University of Helsinki, and today is going to talk about painful intelligence, what AI can tell us about human suffering. So took an undergraduate degree in mathematics at the University of Helsinki, followed by a doctorate of technology in information science, the title of which was Independent Components Analysis, a Neural Network Approach. This was really how I got to hear of Aapo, and that was in the Redwood Theoretical Neuroscience Center in Berkeley, where Bruno Olshausen's work on sparse coding, has a lot in common. And I think I heard a lecture on nonlinear ICA at one point that I found very impressive and inspiring in 2017. So from 2016 to 2019, Aapo held a professorship in machine learning at the Gatsby Computational Neuroscience Unit in UCL, where Peter is sort of one of the organizers. And Aapo has published a number of books, including one on independent components analysis, one on natural image statistics, but most recently, this open access ebook on the lessons that AI has for understanding human suffering through a computational lens. And that's what we're going to hear him talk about today. Very excited to do so. When you're ready, the floor is yours.
Yes, thank you very much for the nice introduction and for inviting me here to this rather warm island, I would say. Okay, so yes, I will not talk about independent component analysis. I will talk about my new book, which kind of combines AI, neuroscience, and even some philosophy. So I'm basically using AI as a kind of a model or a metaphor for the human mind, which is of course not terribly different from what people usually do in computational neuroscience or cognitive science, but this is perhaps on a little bit more abstract level, I would say. So the basic framework or the basic kind of assumption in this theory is that suffering, in particular human suffering, is based on frustration. Now, what frustration is, I define it in two different ways. One is it is not achieving a goal, and one is that an agent is not getting the reward it expected. Now, of course, AI has a lot of theories about how agents plan to achieve goals and how they learn to maximize rewards. So it's clear that AI has something to say about frustration. So, and what is the most important thing is that using these theories, we can actually understand the causes of frustration. And if we can understand the causes of frustration, then we can basically develop interventions to reduce suffering. And well, it turns out that the theory implies a number of different interventions, which turn out to be very similar to what is proposed earlier in Buddhist and Stoic philosophy. So, part one of the book is about the definition of suffering. What is suffering? So I start from kind of respecting scientific priorities. I start from very ancient philosophers. Well, Buddha is well known to have some ideas about suffering. So here's a well-known quote, which is that union with what is displeasing is suffering, this separation from what is pleasing is suffering, and not to get what one wants is suffering. But also here in Greece, kind of here, there were the Stoic philosophers, the most famous of whom was perhaps Epictetus. So here's a quote which says that desire promises the attainment of that of which you are desirous, and aversion promises the avoiding of that to which you are averse. However, he who fails to obtain the object of his desire is disappointed, and he who incurs the object of his aversion is wretched. So now what I have here highlighted in blue are very clearly cases of what we would usually call suffering, which, well, at the top you see not to get what one wants is suffering. Well, it is actually frustration according to a very basic dictionary definition. And also with Epictetus, he who fails to obtain the object of his desire is disappointed, same thing. And in fact, if you look at the whole, all these different cases given in these quotes, you can actually interpret the rest as well as something like frustration. So the basic assumption in this book is that this is really the main mechanism producing suffering. Okay, so now starting from AI, from the very basics, well, in AI, we have this theory of intelligent agents. So of course, one branch of AI, which is very different from kind of simple AI that is typically used in real life, but I'm sure many of you have seen some examples of this. Well, the basic idea is that we have agents, and agents act in an environment with some kind of a purpose, for example, to achieve some goals or to obtain rewards. And the important thing here is that all these actions influence the world where the agent acts. Because of this, basically this loop of agents acting and that influencing the world, the agent has to learn to understand the dynamics of the world, and in particular to predict the future based on its actions. So this is how you make like robots or game playing agents. Here I have a funny picture of actually robots playing games, self-driving cars, and that kind of applications of AI. So now if you open a book on AI, very often they will actually start with the idea of agents and planning. So planning is really the most basic model of an agent selecting actions. So in the basic case, the world is conceptualized as a set of discrete states, such that each state describes everything that you need to know about the agent as well as the world. So for a robot, it would include the physical location and orientation of the robot and everything else in the world. Or in a simple case, it would include like the positions of the pieces on a chessboard. Or for example, in a Rubik's Cube, well, it's kind of clear that it includes like all the colors of the different sides in the cube. And then the agent has a number of actions it can take, and each action takes the agent to a new state, for example, a new location. Often these transitions are stochastic, which means that there's some randomness, for example, an obstacle may appear. And now the point in planning is that one of the states is designated as a goal state. And the computational problem of planning is to find a sequence of actions, that is a plan, that takes the agent from the current state to the goal state. Now, it is very well known that this kind of a planning is quite difficult computationally, because the number of possible action sequences grows exponentially as a function of time steps. So like here's this is often illustrated by this kind of a search tree or graph, where, for example, we start here at the root, and then there's just two actions, go left or go right. And then obviously all the combinations of left and right, the number grows exponentially and the tree gets wider exponentially fast. And so this is why planning is very difficult. That is presumably why it's so difficult to solve the Rubik's Cube, for example. You just cannot like imagine the too many steps forward in your Rubik's Cube. Okay, so now that we have these basic concepts of planning, a goal state, and so on, well, we can basically go on and define frustration as well as desire, which is a very closely related concept. So a definition of desire, well, the first definition is as follows. So we have an agent that chooses a goal state. It makes a plan to reach the goal, and it acts according to the plan, but then the agent fails to reach the goal due to some randomness in the environment, obstacles, or whatever. So this is really defining the ways. Well, okay, sorry. Let me first go to the definition of desire or wanting. So desire and wanting, I use them basically synonymously. So now in step one above, well, I say that the agent chooses a goal state. But then, well, what is the mechanism that chooses the goal state? Now we can actually define desire or wanting as the system that chooses the goal state among all the possible options. So for example, if your perceptual system detects that there's chocolate nearby, then your system might choose that, okay, getting the chocolate, that is the goal. And that is in fact what we would usually say that I want as describe as me wanting the chocolate. Now, if we combine these two definitions of frustration and desire, we see that frustration is exactly not getting what one wants, which is exactly the kind of a typical dictionary definition. So the desire defines a goal state, but the agent fails to reach the goal state. Right. But okay, so that's kind of very, very basic, elementary. Maybe some people might think it's kind of an old-fashioned AI. Of course, these days when we do AI, we would usually do it by machine learning, which is often something like minimization of errors. So the kind of basic principle of thinking in current AI is that programming intelligence is quite difficult, so better learn intelligence from the data. And if you think of a classical example like linear regression, a very trivial example perhaps, so you basically you learn linear regression by minimizing a squared error, some kind of an error in your predictions, as well illustrated here in a very well-known example. So my point is that very often machine learning is based on minimization of errors, which we will actually use a bit later on the following slides. In fact, most of current deep learning can be seen in this slide, especially like supervised learning. It's just that we have, highly complicated functions, nonlinear functions that are being learned instead of a linear function. Another point about basic machine learning is that this learning is typically often considered incremental, which means that you basically make repeatedly small changes to the parameters based on errors in single points. Well, this is the basic definition of a stochastic gradient descent when you minimize, for example, the squared error in some regression task. Okay, so now if we go combine these two, so how do we do something like planning, that is action selection, based on learning? Well, this takes us to the theory of reinforcement learning. So it's basically a theory about intelligent action without planning. This also we forget the idea of goal states, and we generalize that by the idea that there's reward to be obtained, positive or negative reward to be obtained at different states, and you basically want to maximize that reward by your actions. And then you use a theory basically, which is a bit like a kind of a stochastic gradient, or well, I should say an inline approximation of dynamic programming, so that you learn the best action to perform at every possible state. So then we see that we basically have no planning at all. So and therefore we avoid this exponential explosion in the planning tree. You actually know for each state exactly what is the best action by this kind of a dynamic programming system. So you can actually act very fast, as if in a reflex, some people would say. But then there are also disadvantages. One is that action selection is inflexible. In neuroscience literature, this is often compared to habits, which you do kind of automatically, but in a very inflexible fashion without actually taking into account the context very well. And of course, learning can be slow because you must repeatedly visit every state to see what the dynamics are from each of those states. So basically, you don't need to use computation for the planning, but you need to use a lot of computation and time for the learning. And this is presumably how like Boston Dynamics makes its robots do all kinds of funny stuff. They can actually jump and so on and so on. Okay, so how does this then relate to frustration and suffering? Well, in the theory of reinforcement learning, there is actually a very well-known quantity called reward prediction error. I'm not giving a very formal definition here, just a kind of a basic idea, which is that there's an expectation of reward at every time step, and then there's the obtained reward, and then you basically take a difference of those two. Now, this is a fundamental quantity in the sense that, in fact, it can be proven that reinforcement learning is possible simply by minimization of the squared reward prediction error, summed over all the states and actions. So you can actually do learning based on, you can do all the learning needed by simply minimizing these errors. So now we can define that negative RPE, negative reward prediction error, is frustration. That is the same thing as what is called reward loss in some parts of the neuroscience literature. It simply means that the reward was less than expected. So it's clearly a kind of a generalization of this idea in some sense, at least a generalization in some sense, of the idea that you plan, you act according to a plan, and then you don't get it. But here we have a case where you can actually get like rewards anywhere, and then at every time step you in fact can compute this kind of a error between the obtained reward and predicted reward. It also shows that frustration has its utility. It's actually a learning signal. That's presumably the evolutionary function of frustration. Although it's clearly it is more complicated, because to learn we actually need to minimize both the positive and negative sides of the RPE, while only the negative one is frustration. But also here we see this idea that learning is incremental, like in some kind of a stochastic gradient descent, so that you actually use every instance of frustration. You can calculate the reward prediction error for every time point. Yeah. So, well, you can basically, according to this definition, then you can have frustration at every time point. Okay, so at this point, I just like to address a critique that somehow pops up at this during this talk at some point. So people say that, well, a computer cannot suffer, so we cannot actually model suffering with AI or any computational methods. Well, I think this critique is not any more or any less valid than for any computational neuroscience topic. So most brain and mind phenomena have different aspects, including the subjective experience of feeling, which is like more like on a consciousness level. And then there is the information processing or cognition, and of course, many other aspects. So this is, I mean, the case like in vision, for example. So you have the visual perception, which is a subjective experience, but then you have a lot of sensory processing. So a computer probably doesn't feel the suffering in the conscious level, but it doesn't matter because it can still be a very useful model for the other aspects. In particular, the utility of the information processing level, understanding that, is that then you can elucidate the conditions under which information processing, which is related to suffering, appears, ideally even information processing that is causing the suffering. And then you can find interventions to reduce suffering by finding interventions that decrease such information processing. So what I'm saying is that this, in some sense, this critique applies to anything like vision, like I just said. You could say that, well, computational vision is pointless because, well, we don't understand how visual perception happens on the conscious level. But of course, nobody's saying that. So I'm saying that in the same way, we can do a lot of modeling about suffering. It's not that it's somehow uniquely conscious, as some people intuitively might think. Okay, so that was part one. Now part two, why is there suffering? So I'm here in particular focusing on different causes of different properties of the world and the agent that that lead to suffering. So there's actually several chapters in the book on this topic. So I'm just going to go like about some kind of a random sample of a couple of topics. But these are focusing on the concepts of uncertainty, uncontrollability, and what I call unsatisfactoriness. So uncertainty, this can be approached from the viewpoint of perception. If you open any textbook, they will tell you that perception is a difficult inverse problem. It's often illustrated like this, so that we have like a three-dimensional cube, but the eyes only receive a 2D projection. Well, maybe two of them, but it doesn't make a lot of difference. And so from just these pictures, you wouldn't be able to tell that it's actually the same cube. The same cube just seen from different angles. Well, actually, I would, from my viewpoint, that's actually a very weak way of demonstrating that perception is a difficult inverse problem. I mean, anyway, there's clearly very strong limits on your perceptual system. You cannot see through walls, for example. So clearly, the information that you get in your perceptual system is always incomplete, always insufficient. Now, people assume, since Helmholtz, 19th century, people have assumed that the system tries to cope with this problem of a difficult inverse problem by using prior information, which is often modeled as Bayesian inference. So here's one example that suppose we see the stimulus on the left-hand side. Now, we can have two different interpretations for that. One is that, well, it's kind of a circle occluded by a square. Or we can think that, well, we can interpret that it's actually a Pac-Man that's trying to eat the square. But usually people immediately jump to this conclusion here, presumably because the prior probability for this kind of a constellation with a circle and a square is much higher than the probability of Pac-Man and a square. I think Pac-Mans are actually not real beings anyway.
Oh, yeah, that's right.
Yeah, right, yes, yes. So this perceptual inference based on Helmholtzian Bayesian ideas, it's uncertain and it can go wrong. This is illustrated in textbooks by various visual illusions, like here's the famous Kanisa's triangle. Now, if you look at this and, well, at least under suitable conditions, you know, viewing distance and so on, you will see a triangle here, in the sense that you will actually think that there's a contour going here. But of course, well, I'm not sure if you see that, but well, let's assume you see it. But of course, there is actually no contour here, in the sense that this is all just the same white pixels here. But your visual system tends to like construct a kind of a contour here, an edge. Now, so this is an extreme example, of course, of this uncertainty. But it illustrates that there is always some kind of uncertainty. Well, very often, at least, there is some uncertainty about what you actually see. And so uncertainty implies logically unpredictability, and then this necessarily increases the reward prediction error, because that is a measure of unpredictability and thus frustration. So we see that uncertainty is like one ingredient that actually increases your frustration and thus suffering. And when you take this logic a little bit further, you will also see that, well, actually, even the reward loss, even the reward and the computed reward loss or reward prediction error, it's only actually a percent. And so now, slightly perhaps anticipating like later developments, if we want to reduce suffering, we should also take into account the fact, we should understand that actually the reward loss is certain, and you shouldn't actually take that frustration always necessarily very serious. Here's an interesting quote on this topic from yet some other Greek philosophers, although in fact Sextus Empiricus, well, he has a Latin name. I think he's usually assumed to have worked in Alexandria. But the skeptics, Pyrrhonian skeptics, have a lot of examples of why you cannot trust your senses, and therefore why you cannot actually trust even your own thoughts, because thoughts are derived from the senses. So like here, when we press the eye from the side, the forms and shapes and sizes of the objects we see appear elongated and narrow. And therefore, we shall not be able to say what each existing object is like in its nature, but only how it appears. Okay, so that was uncertainty. Then the other kind of unpleasant property, so to say, I'm talking about is uncontrollability. And here's one example. This is just one example of that uncontrollability, which is wandering thoughts. Something that's kind of a topic of a lot of intense inquiry in experimental psychology as well as neuroscience these days. So what it means is that, so you are trying to focus on some task, but then very often unintended thoughts invade your mind. Well, this is something that certainly everybody has experienced. It's illustrated here, where people are trying to focus on something serious, but then they kind of fantasize about being a Superman or being on a nice vacation. And this man is kind of an outlier, apparently. Now, in the literature, people have been analyzing what the contents of these wandering thoughts are. And it seems that most of them can be classified into two categories. One is that you are planning the future in more or less realistic ways. Like, well, this is a slightly less realistic way. This might be a more realistic way. Or then you are remembering the past. So what you did last week and that kind of stuff. So this is actually clearly a reflection of uncontrollability of even your own mind, because, well, you are trying to focus on a task, but you are just not able to do it. So why does this happen? Well, a simple idea might be that maybe your brain gets tired, there's fatigue, and that's why you can't focus anymore. But I don't know if that's very plausible and whether people are taking that very seriously. Here's a kind of a computational hypothesis, which is not incredibly original. I think it has been around for quite a while, which is that basically the idea is that when there is nothing really urgent for you to do, you are focusing on something which is a little bit boring and doesn't perhaps sound incredibly useful to use in some evolutionary sense, at least, then you use your brain capacity to do simulations. And simulations have exactly these two, they take these two forms. One is planning future events and replaying past events. Now, it should be clear why planning future events is useful, because planning is computationally expensive. So if you really don't have anything, if it appears to you, it appears to your brain that there's nothing, you're not doing that, you don't have anything else to do, why don't you then just use your brain resources to do some kind of planning or what you might do tomorrow or next week? Now, it may be much more counterintuitive of why you would replay past events, because, well, I mean, you already got them and you, in some sense, you already processed them. But it is comprehensible when you think that this learning, it tends to be incremental in the sense of like stochastic gradient descent or any similar online algorithms. So then you really have to like, input the same data points many times. I mean, if you have scarce data, you really want to like input the same data points into the systems many times to take many stochastic gradient steps. And in fact, this kind of replay is very well documented in the brain. A lot of experiments on rodents, like in this figure here. And of course, it's very widely used in AI. So what we see from this viewpoint is that wandering thoughts are useful, but they are also painful. Why they are painful is that they basically multiply suffering, because you repeat past frustration and even imagine possible frustration that might happen in the future. So you're kind of multiplying these unpleasant things by simulating them many, many times, and even inventing in imaginary frustration. Okay, so in addition to the uncertainty and uncontrollability, I have here this kind of a third property, which is called, it's a bit of an umbrella concept, which I call unsatisfactoriness, kind of inspired by Buddhist philosophy. So it's kind of an umbrella term for many things, but what I'm doing here is to basically point out two possible computational interpretations. One is that, well, since frustration is about comparing obtained reward with the expected reward, that is the predicted reward, well, these expectations, of course, they can change. And actually, if you have an intelligent agent, then it will basically relearn the expectations all the time. So what it means is that if you get a lot of reward, then that amount of reward will become the new expectation. And you will basically like never really get a lot of pleasure in the sense of getting more than what you expected, because your expectations are always then increased and increased. So this is what I call insatiability. Your system will never be insatiable. It's the same thing more or less that what some people call the hedonic treadmill. So your brain just forces you to like always want more and more and more. Another point, another kind of unsatisfactoriness is that these goals and rewards that we are pursuing are more or less dictated by evolution, together with some cultural influences, of course, but I'm kind of taking a rather biological approach here. But another point is that these goals and rewards by evolution, they are not designed to make us happy. Evolution has no interest in making us happy. It's just about spreading genes and that kind of stuff. So that leads to the interesting case, which we have certainly all experienced, that we might wish to change our desires, but we cannot. So we want certain things, but and we kind of realize that this desire is not a good thing for us, but we just cannot change it. Which is related to the fact that, well, something I discuss at length in the book, which is that, well, there's a in neuroscience and psychology, there's the well-known dual process framework, where we have basically like two different systems of processes in the brain. So, for example, one aspect of this is that we want things that actually give no reward in themselves. They only claim to predict it. Like sweet taste basically predicts that you get energy from food. But of course, it might not actually be, the prediction might be completely false. It might be just artificial flavorings. And even if it's real sweet taste, well, maybe it's actually not good for you. And that is a desire that you might want to get rid of. So these are what I call evolutionary obsessions. Obsessions in the sense that you really like want things that you desire, that you realize are not actually very good for you. So here's a kind of recapitulation of some of these causes and mechanisms of suffering. So we had in the beginning, certain problems in the world, which is that the world is highly complex. We don't have enough data, like sensory data is insufficient. We also have insufficient computation, like planning is very difficult. And then we are programmed to maximize rewards by evolution or something, or an agent is programmed by a programmer, and we cannot change those rewards. So then these lead to these properties of uncertainty or unpredictability and uncontrollability, and then this umbrella term unsatisfactoriness, which includes insatiability and obsessions. And now in the book, I go then into a greater length in regarding like different processes that then actually increase the frustration and increase suffering. But here I don't really have time to go into them. I just mentioned this one, which is simulation and wandering thoughts, which basically multiply the suffering that you would anyway have by basically repeating it many times. And so these are the reasons why you get error signals and frustration, and which then leads presumably to the conscious feeling of suffering. Okay. So that was part 2. How am I doing with time?
Well, it's 11, so you have 20 more minutes.
20 minutes.
Including questions.
Okay. Yeah, okay. I always run out of time, of course. Yeah. Yes. Okay. Yeah, so the third part is about designing interventions. And as I said, well, these interventions then turn out to be rather similar to the Buddhist and Stoic philosophies. This is probably the most original, scientifically speaking, of the book. Most of the stuff are actually reasonably well. Most of the stuff before in the first 2 parts of the book are reasonably well known in some branches of like computational neuroscience, perhaps. But then here, when I design these interventions and connect them to Buddhist and Stoic philosophies, this has probably a little bit, maybe quite a lot more scientific novelty. Okay, so there's a number of different interventions that can be made. Well, the main principles here are really like reducing expectations and meditation. So I kind of summarize the ideas about frustration in a kind of a informal equations, which is that frustration is basically the product of 4 different things. So what we start with is that we have the difference of the expected and obtained reward. Well, that's the very basic definition of frustration. But then we take into account the fact that actually we only have a perception of that. We of course have no access to any ground truths. But then this perceived frustration, so to say, is modulated by a couple of terms. One is the level of certainty attributed to that perception of the reward loss. As I said, well, we have to take the uncertainty into account. I will have a bit more on that. Then we have a term which says how many times it is perceived or simulated. Well, that's a slightly okay, this can be misinterpreted, but it's really a question of like how many times we simulate this in addition to the initial perception. So it's like perceived once, but then it can be simulated as many times as the agent wants. And so that's a multiplicative effect on the frustration. And then there's a 4th term which is in gray because I didn't actually have time to go look at it in this talk, but in the book there's much more about the kind of amount of attention paid to this frustration. Also, I discussed the case of metacognition of the frustration and that kind of stuff. Yes. Sorry?
Exactly how painful that's going to be.
Well, I think the claim here would be that it doesn't really matter what the sign is. So if you expect a certain amount, okay, so here's 0. So you assume like a certain amount of negative reward, but then if you actually get less, I mean, even more negative reward, so then that's suffering. But if you get less, I mean, you don't really suffer because so you were expecting something bad to happen, but it didn't really happen. Only something mild.
Wait, somebody cut my hand up. I don't suffer.
Okay. So yeah, okay. So one thing that okay, maybe I should speak here. So one thing that I didn't mention here, which I emphasize in the book, is that it is really about kind of psychological aspects of suffering, not physical pain. Physical pain is a different thing. So it is true that physical pain has much less to do with expectations and so on. There's actually some recent work where people apply, you know, like Seymour and those people, they have papers on like how you could actually apply the well-known frameworks of Bayesian perception and so on pain, because pain is fundamentally also a perception. But clearly pain is like much less somehow dependent on expectation and intervention. These interventions are not for physical pain, so that's a different thing. Okay. So you mean that? Yeah. Well, yeah.
It seems really simple for positive. Negative rewards seems like, you know, negative rewards are bad.
But I think, okay. So this, of course, gets a little bit hand wavy, but I think, suppose you assume that something rather bad happens to you. Now, you would probably still not believe it completely. You would think that, well, maybe it doesn't actually happen. Maybe she doesn't actually leave you. And that's why your expectation is a bit higher. No, but I mean, there's still some uncertainty. And that's why your expectation is a bit higher. But, you know, once you actually like completely know, are completely certain that this bad thing is going to happen, then I think different psychological processes will start happening. No, there's different uncertainties here. Yeah? So there's uncertainty of perception, and there's the uncertainty in your expectation of the reward.
So negative rewards are always perceived. You have to make a case.
Well, I mean, if you expect something bad to happen to you, you will probably usually still have some uncertainty, and therefore your expectation will be higher, less negative than the thing that might happen. So when it actually happens, it will still feel like suffering. That's one way of explaining.
That means it's always pleasant.
But okay, anyway, I partly admit your point that positive and negative rewards might be different. And there's apparently some neuroscience results in like fMRI of the human brain at UCL, of course, about how they might be coded some slightly in slightly different cells. Sorry? Exactly, yes. But I'm here kind of assuming that there is no difference. But yeah, okay, maybe there is. Future research. Okay, yes. Oh, yes. Okay, so now to reduce frustration, then what we need to do is to reduce any of the terms here on the right-hand side, because they are all multiplicative and they are actually all positive. Here we have kind of just taking the positive part. And this is really the basis of the design of interventions. So what we get is that, well, the most fundamental thing is to reduce the expectation of your rewards. Well, that's kind of absolutely clear that you expect less, and then that will decrease your frustration. But then the question is that how do you reduce expectation? Now, if you recognize the uncontrollability and uncertainty of the world, which is well known in Buddhism and Stoicism, and in Buddhism it's called impermanence, well, that will reduce the expectations. Now, I admit this is mainly true for positive, in the positive case. In the negative case, yeah, it might be actually quite different. And also then people, these philosophies recommend that you somehow recognize the general unsatisfactoriness of the world even in some kind of a very general hand-wavy sense. So here's a very funny and famous quote from Epictetus. So if you're going to bathe, picture to yourself the things which usually happen in the bath. Some people splash the water, some push, some use abusive language, and others steer. And so when you go to the bath, you will have rather low expectations of kind of things going, your enjoyment or something, and then you will not be disappointed. Okay, then another thing is that you can reduce the certainty attributed to your perception. In particular, the perception of the reward loss. So you think that you got less than what you expected, but maybe all those perceptions are a little bit wrong, or at least they might be uncertain. So, like a very trivial example of how you would handle this that computationally is that if you take an average of many observations of xi, and you know that they have different noise levels, then you should weight them by the inverse noise variances. And in fact, there's recent theories on how you would do this in reinforcement learning, and you will exactly see that you should modulate the reward prediction error by some kind of a measure of the noise. There's a paper by May and others, 22, I think. Sorry, I don't have the reference here. And well, okay, I skipped some of the other stuff. Okay, I skipped this as well. Okay, so then there's meditation, which is of course very well known in the Buddhist context. Basically, it means something like you focus on your breathing and observe phenomena occurring in the mind. Now, meditation is an extremely complicated, highly complex topic. And I think what's happening during meditation, there's probably like many different mechanisms happening that actually create the well-known effects of meditation. But I think based on this theory that I have in the book, we can have a couple of explanations of why that might happen. So one thing is that, well, when you make the mind empty by this kind of focusing on the breathing, people quite consistently, not everybody, but many people report that they feel a lot of joy and bliss. So why would this be so? Well, one reason would be simply that it prevents all this simulation of frustration. So you don't imagine bad things happening to you. You don't recall bad things that happen to you. And that's why then that reduces your frustration. Although it's still not clear why people actually feel like positive joy. That's, I think, a very interesting open problem. Another idea that I propose is that meditation basically speeds up learning. Because the idea was that you should learn that the world is uncontrollable and uncertain. Now, when you do meditation, you actually see these things kind of happening in real time. So you see that, for example, when your mind starts wandering, well, that's uncontrollability. You see how your perceptions may change depending on like slight changes in context and so on. So that's a question of uncertainty and impermanence. And so because the learning is fundamentally incremental, you need repetitive observations like this. And therefore, well, this is simply a much faster way of learning about the uncontrollability and uncertainty of the world than ordinary life. Also, as I mentioned, there's this idea of metacognition. I think when people do meditation, they basically learn to observe what happens in their mind on a metacognitive level. So especially in Buddhist philosophy, people often talk about some kind of a cycle of cognition that's happening. So in the book, I actually rephrase all this in terms of well-known ideas from like computational neuroscience and planning. And now the idea is that when you are able to observe this properly, you also obtain some amount of control on it. So you can basically stop the process around something like desire. And so then you can actually, there will not be any there will not be any frustration if you actually can stop this process around desire and get rid of the desire in the first place. But okay, I will not go into details. Okay, just, do I still have 2 minutes? Yes, okay. So some problems for future work. So I had two definitions of frustration, which are in some sense a little bit incompatible. I was saying that frustration is not getting what one wants, But then in the RPE case, it is not getting what one expects. So are they the same thing or not? Then another question is that, is the expectation of reward necessarily defined by probabilities? There might be other kinds of expectation, not in the kind of a probabilistic context, not coming from the probabilistic context, like something about like social norms and moral expectations, like I expect people to treat me in a certain way. Then is suffering really all about frustration? Well, of course, it's just one theory, which may be very important and may explain a lot, but maybe not everything. There's a well-known theory in contemporary medical philosophy by Eric Cassel about the idea of suffering being mainly about threats. So in the book, I discuss a lot, like kind of the connection between these two ideas or theories. Well, then if we have this, when we have these interventions, well, they might also have negative side effects that remains to be investigated. Then there are certainly like some aspects to suffering that are clear, some aspects of let's say the human being that are clearly relevant for suffering, which I don't consider here. One is social interaction, another one is culture and society. Then there's the idea of the body, and finally the meaning of an activity or even the meaning of life. And then of course the question is that, can we actually measure the quantities involved that would really like unleash the potential of computational modeling? And there might also be some very practical technological applications in like human-computer interaction or say AI. Okay, conclusion. So it's kind of a combination of AI, neuroscience, and philosophy. So most of the book is really a review of ideas, mainly found in the literature. I really try not to make any new hypotheses or like any new claims. I'm just trying to like take things which have already been proven and then reinterpret them in a new framework. Although of course that is not always possible. So this approach really emphasizes the idea of frustration, which is clear, which is also the aspect or the mechanism which is strongly emphasized by Buddhist, Stoic, and Stoic philosophies. So we have these problems of uncertainty, uncontrollability, and unsatisfactoriness, which are kind of some kind of a causes of suffering. Now I say that the title is Painful Intelligence, which using that title, well, of course, it's on one hand, it's just a fancy title, but there's also the point in the book, not really made explicit very well in this talk, which is that intelligence may increase your suffering. We saw some mechanisms like we have this repeated simulation, which multiplies suffering. We have the adaptation of expectations. And there's also cases like the errors can be based merely on predictions, like RPEs, although I didn't have that in this talk. And in the book, I talk a lot more about things like self-related processing and interrupts. So those are really the justifications for saying that intelligence is, in a sense, painful. Although, well, that's not really the main point of the book. The main point of the book is to understand the mechanisms behind suffering and design interventions. And okay, so what's the point in computational modeling? That's of course something that people always ask. I mean, experimental neuroscientists ask. Well, here I think what we see is that by computational modeling, we can actually make causal connections explicit, possibly even quantifiable. And that should enable design of new interventions. Well, we had this frustration equation, and based on that, it was actually possible to design all kinds of interventions and probably also many more. Okay, thank you very much.